Hey, it's been a while. Yeah, just a little while. But anyways, I'm back now with a new series where I'll be giving you some beginner tips in Roblox game dev. We'll start with some basic scripting, so let's begin. First, we're going to need a script. To create one, make sure your Explorer tab is open. If it is not, just click on View, then open it from there. Now, hover over Server Script Service and click on the plus sign. Click on Script, and that should open up the script for you automatically. You see this print function? Keep it in the back of your mind for now, but delete it from the script. Now let's talk about variables. Think of a variable as a box. A box is simply a container that holds something and can have a label on it telling us what's inside. Similarly, in this case, a variable is just a container that holds a value. We usually give variables descriptive names to indicate what the value is for. These values can be a variety of different types, but the ones you need to worry about for this video are just numbers, strings, and booleans. A string is just a collection of characters, like ABC, hello123, or just any other text. Booleans, on the other hand, can only be a value of true or a value of false. Now I know numbers might seem obvious, but they're usually divided into separated categories, with whole numbers called integers and decimal numbers called floats. These can be divided into further categories if you're familiar with other programming languages, but for Luau, there's only one type and it's just called a number. Easy enough, right? Now, to define a variable, start by local, then the name of the variable, and then assign it a value. Don't worry about local for now, we'll get to that later. Now open up the output window by going back to view and clicking on it. Remember the print function? We haven't went over functions yet, so all you need to know about it is that you can pass a value inside the parentheses and it prints it in the output window here. With variables, you can also reassign them to new values if they are already declared. In this case, we don't really need to write local as we're not declaring anything new, we're just changing a value. And of course, the change is reflected when we print it here. In Lua, you can do any basic arithmetic with numbers like addition, multiplication, subtraction, and more. You can always print the results to see what they evaluate to. These values are typically going to be stored in our variables, which means we can use them instead of hard-coding values. There's even an operator to join strings together. You use it like you're adding strings together, but unlike in other programming languages, it's not a plus sign, it's two dots. And of course, you can print the result. Now let's talk about tables. When we code, we usually need a nice way of grouping values together under one label instead of multiple, which is where tables come in. A table, also known as an array, just holds a list of values where each value can be accessed using its position in the array. To define an array, just start as if you're writing a variable, but instead of assigning a single value, you can assign multiple values separated by commas and then wrapped inside curly brackets. Let's say we wanted to access the second element to print. We first write the array's name, and then in square brackets, you specify the position of the element you want. I'm going to show you that it prints, but I want you to try changing the second element in the array and rewriting to see what happens. Now, a position in an array is called an index, and it's usually a number. Wait, usually? Yes. Let me introduce you to dictionaries. In a dictionary, instead of numerical values for the position, we use strings and call them keys, which allows us to have a key value pair configuration. To define a dictionary, instead of comma-separated values, give the values a key by structuring them similar to a variable declaration, starting with the name, an equal sign, then the value for that particular key. Let's add a few more so I can show you the syntax and print them as well. Notice the consistency of the casing. That's because upper and lowercase letters are considered different. So if you use a lowercase where we need to use an uppercase here, it will not work. The same goes for function names, variable names, etc. We already saw how you can reassign a new value to a variable earlier. We can do the same with arrays and dictionaries as well. Of course, we can reassign it to a whole new table, but that's not as useful as changing elements within the table instead. To do this, we follow what we did when we wanted to retrieve the value, that is, name of the table, and then the index or key of the element you wanted to access. But now we use the equal operator to assign it to a new value. I'm showing you an example with a dictionary, but for an array, just use the index and it's basically the same. Imagine we have this section of code here. We're using two numbers to calculate a result, and we have the same code repeated, with only the difference being what numbers we choose. Now let's say I wanted to make a change to the formula. I will need to go through each section and change it one by one. What if I only have to worry about changing it once? This is where functions come in. We'll start by defining one first. To define a function, like a variable, we start with local, then function, then the name, add brackets, and finally an end statement to indicate where the function's block of code ends. Now anytime we call the function using its name, we can run what's inside it. The flow of execution starts as normal, top to bottom, and when a function call is reached, think of it as jumping to here, running what's inside, and then when the end is reached, it jumps back where the function was called. Let's put the code we had before and calling it 3 times. Now when you run it, you see the result printed 3 times, once per each function call. And we solved the original problem by making our lives easier, because if we change the formula now, we just do it once, and it's reflected for each function call. Nice. But wait a minute. Remember how we had different values for each section of code? Should we just have 3 different functions with different names? Wouldn't that just be going back to the original problem we had but with uglier code? True. So instead of doing that, we can have our function take arguments between its brackets and use those instead of card coding the values directly into our function. Let's take the numbers and put those as arguments, since they're the ones we want to change each time we call the function. Now when we call calculate, we can pass the values that we want to use for that particular call. Now our function is flexible, and our code looks much cleaner and simpler to understand. Nice. There are a few more things you need to know about functions. Conventionally speaking, it's better for functions to fulfill one task instead of multiple. Our function right now does two things. The first is that it calculates the result, and the second is that it prints it. We can remove the printing out the function, and now our function does one thing, and that's calculating the result. But how do we print it now? If you move the print statement out instead of removing it, that part of the script won't have access to the result variable, as it's outside the scope of the function. What does that mean? We'll get into that next. But for now, there is a way where we can expose the result's value so it can be printed outside the function. We just need to add a return statement to give back a result. Remember how when end is reached, Luau jumps back to where the function was called? Now it jumps back when return is reached, but the value that we returned gets placed inside of the function call. So if we set a variable to the result returned, it will contain our result, which we then can print. You can also just print it directly without storing it first. Now keep in mind, since Luau jumps back when return is reached, no code after it is executed. Now let's talk about why result is not exposed outside the function. If you remember, I mentioned the concept of a scope. Variables declared outside can be accessed anywhere within the script, but since our variable is created within the function, it gets cleared from memory when the function's execution ends. So its scope is limited to the function, but this behavior is only because we're declaring our variables as local ones. That means they will be local to their scope, meaning anything that is inside the scope, it will have the same access. If we don't declare our variables as local, they will be global to the whole script by default. So for our example here, once calculate is called once, the result is set globally, and we can access the value outside the function. But conventionally speaking, this is really bad code. We need to limit our variables to the scopes they will be used in. And hey, if you don't care about convention, at least care about performance, as local variables are more performant than global ones, so use them whenever is possible, even if the variable is global to the whole script anyways. If you remember, I mentioned that there was a few ways we could have solved our issue earlier when we needed to print the value of result outside the function. If we moved the result variable outside and had the function modify it globally, then we can print it right away without returning anything. This is not as bad as having result just be a global variable, and it might even be useful in some specific cases, but speaking conventionally again, you want to keep your function's behavior contained. Notice how we have been using the print function this whole time without defining it anywhere? Well, that's because the print function, as well as some other ones, are part of the library of helpful methods Luau provides for you. You also notice a special highlighting of some words we have been using like function, local, etc. These are called keywords. Keywords and the names of methods in the library are reserved, so you should not use them as names for your variables or functions. Now let's get into if statements. We're going to start with defining one first. To define an if statement, you start with the word if, you condition, and a then. And of course, ending the block of code with an end similar to functions. Let's add another one that does the opposite of this condition here to cover a case where there isn't enough coins. If statements allow us to execute different code depending on a condition. The condition is just a comparison that evaluates to true or false. For example, the first condition won't evaluate to true because there isn't enough coins, but that will have this condition evaluate to true, leading to the code within to be executed. We can pretty much compare anything. For example, we can check if the name matches a value using the double equal sign. Don't forget, double equals for comparison, single equals for assignment. Let's print to see the result. As you can see, since we don't have enough coins, the second statement's code ran instead of the first one. And since we have our name set to Skelly, the third if statement's code was executed. There is more. We can also chain conditions together in the same line, either through the AND or the OR operators, or even negate a condition. For example, here we're checking if the name matches. We can check if the name doesn't match by just putting a not. Another way to say not equal to is using this operator. It is equivalent to the previous statement. Now, since we know these conditions are opposite to each other, we can combine them into a single structure using an else statement. This way, if there isn't enough coins, this is ran instead. You can also combine if statements into the same structure if they are mutually exclusive using the else if. There's several things uncovered here. I would suggest taking a look into the Creator Hub documentation to read more about them. Link is in the description down below. Now it's loops time. Loops are just blocks of code that are ran constantly till a condition is met. We have a few variants, while loops and for loops. We use while loops when we're not sure how many times the lines of code need to be executed. It runs till a condition is false. To define one, we start with while, then the condition, and then a do, and marking the end of the block with, you guessed it, an end statement. Let's print something and make sure to add task.wait, which just pauses the execution for a period of time. We'll set that to 1 second. If you don't include it, this will happen. But anyways, now when we run it, you can see it keeps printing every second. It will keep doing that till the condition somehow becomes false. If the condition was false to begin with, it wouldn't run at all. Now, if you happen to know the exact number of times you want to run a loop, use a for loop instead. To define one, you start with for, then your counter variable with the starting value, and then the value it needs to reach. Then you add the step, which is how much the counter goes up by each time. Add a do, and finally an end. This for loop will go up by 1 each iteration till it goes over the end value, and then it stops. You can have it go up at any other value if you want. You can also have it count down instead of up if you would like to make a timer, for example. If you just want it to go up by 1, you can omit the step and it will go up by 1 by default. And you can even stop iterating early by using a break statement, which cuts the execution short. I'll add it under an if statement so it stops running halfway through the loop here. You can add break for both while and for loops. Now let me show you one of the nice ways we can use arrays and loops together. Since for loops are used when we know how many times we need to execute a code block, we can have it enumerate over an array. There are a few ways we can do this. We can hard code the number of elements, which you would avoid as it's not very flexible. We can have hashtag to have it depend on the length of the array. Or we can have an enhanced loop format where we get the index and the value at the same time. And as you can see, they all achieve the same result. The enhanced loop can also be used to iterate over dictionaries. Instead of the index, we would have a key here, so I'm naming it properly. And just make sure to use pairs instead of I pairs. And as you can see, it will iterate over every key and have its value. And that's it. Make sure you check the documentation. I'll link in the description down below, as it has a lot more details for the things we covered. In the next video, I'll show you how to have scripts interact with the world and game objects. If you have any suggestions or questions, then always leave them down below, or even come check out the Discord server. Thanks for watching. See ya.